Today we discuss the experiment of measurement of linear dimensions using mechanical comparator. Aim of this experiment to check the dimensions of the given workpiece with the standard specimen using mechanical comparator. So apparatus required, this is for mechanical comparator, and standard specimens we are using one for mild steel and another one for another different for slip gauges. Then micrometers we have to checking for the standard theoretical value. So description or procedure of this experiment. So the mechanical comparator is one of the type of comparator used to only checking the specimens. See, there are a graduation in the dial gauge and there is a counter dial in the gauge. There is a plunger. So these plungers we have to using the sensitive plunger point. So which has one is 1.1 mm is equal to 0.01 mm. So that's why we have to using here in small circle. So the one rotation is equal to 1 mm, one division. Okay. So this is the plungers acting on the inside the dial gauge. Then the plunger is the pointer with dial gauge out of the reading. So by using the slip gauge, the values of the specimens was verified. So this with the least count of mechanical comparator is 0.01. Finally, we can get is the acceptance of values is same as the comparator and also micrometer, which we have is a acceptable one. So if there is any deviations means if there that component it should be a rejected one. So this is the result of the experiment. Okay, then procedure. So the measure to height of the specimen using vernier height gauge to standard specimen and get the values in mechanical comparator. Check from the deviations from standard using dial gauge. Then check all the test spaces like MS and slip gauges. Note down the variations from that mentioned table. So it should be an acceptable one or rejected one. Okay. So this is the tabulation. This is the tabulation for this is the tabulation for mechanical comparator. So we are first we can take as the dial gauge reading and acceptable reading. So we can getting from the micrometer. So the dimension, so the ranges is 0.25 mm. And the deviations they have means it should be noted that is a deviation. And then finally we can get answer result is accept or reject, that is a output of this experiment. So first we can check, first we can insert the 4 mm of slip gauges. So first we have to check there is any movement, there is no movement inside the pointer. Okay, so there is no deviations from this slip gauge. So already you know the slip gauge, there is no error. Okay, so that's why there is no deviations from the inside the pointer, not be in the dial gauge. Okay, that's why the dial gauge reading there is no movement inside the pointer, so the deviation is 0. Then and also the unit is 0. There is a unit in 0 in mm. Then actual reading we can get as the micrometer. So the value is 4. The deviation is 0. So we can check also the dimension is by using the micrometer. So this is the ranges from 4 mm of the actual reading. Okay, then we can get as the final result of the first specimen. So which is a 4 mm of slip gauge. So the 4 mm there is no deviation of the slip gauge. So that should be an acceptable one. Okay. So second one specimen is mild steel. So we can take in as the micrometer reading. It should be a nearly getting us 6 nearly getting us the values 6 mm. Okay, so already we know that micrometer reading MSR plus TSR into least count. Okay, MSR TSR into least count. So the value is main scale reading is 6 mm. Main scale reading is 6 mm, nearby 6 mm, plus 32 divisions we are noted here. 32 divisions. So the least count of the micrometer is 0.01. So finally we can calculate it. Micrometer reading from this specimen is 6 plus 32 divisions into 0.01 least count. So is the actual reading of the micrometer reading is 6.32. Okay, so we can use this specimen by using the slip gauge, by using the dial gauge reading. So if there is any movement inside the pointer, we have to note it from the deviations of the table. So it should be values are movement are there inside that pointer to be noted as nearly 4 4. Okay, so deviation is 4 mm. So each one is inside the pointer is noted is 0.01 mm. So 4 into 0.01. So the value of the deviation is 0.04 mm. The actual reading already we can get from the micrometer. The value is 6.32. So the deviation is 2.32 mm. Okay, so that is the MS specimen is, it should be a rejected one. Okay, so finally we can get as the result. So the dimension limits of the given workpiece like slip gauge and different material are checked with the standard specimen using mechanical comparator.